Okay, so with microservice architecture, the problem that we are trying to solve is the resource scarcity that we are facing, especially when you are dealing with a huge application. The application itself, is having a lot of issues while we are scaling the application up and down. That's the basic of basic most of the problems that we are facing today. So like we are not talking about 100 users who is coming to a website and doing a small task. We are talking in here millions of users concurrently accessing the systems like uh, especially nowadays there are social media applications, ride sharing applications. So those kind of applications, they are accessing users in millions, and they're doing transactions in various speeds. So we need to have real-time systems, especially when we are talking about systems like ride sharing applications. We need to share information real time. We need to handle thousands of ongoing transactions or ongoing rides. So that's kind of thing how we're going to manage in order to do that. What is the architecture patterns that we can use? So probably uh, there are scaling capabilities that we can do, especially with things like um, when we talk about horizontal scaling or vertical scaling, we can follow along those things. Yes, that is true. But when we are working with huge application, even vertical scaling is not enough. So anyone knows about the horizontal and vertical scaling? What do you understand by horizontal scaling and vertical scaling? Anyone knows? Two scaling mechanisms. Raise your hand if you know what is vertical scaling and horizontal scaling. No idea. Okay, so there are two ways that we can scale an application. The first way is uh, vertical scaling. Other one is the horizontal scaling. But when we are using vertical scaling, what we can do is we can let me double check. Yeah. Vertical scaling, we call the when you're talking about vertical scaling, or we simply call scaling up. You basically what you're gonna do is you're gonna add more computing power. Okay, say for example, you have a machine that is running with 512 RAM and one core CPU. So if you are scaling up, the system is working under these conditions for certain amount of users. But when the user traffic grows, what will happen? The amount of resources that you are having within your machine would not be sufficient enough to cater those users. It's like, think about what do you call transportation system. Let's say for example a bus. Okay, so bus has a limited capacity, right? If there are like 56 seats, okay, you can only have 56 seats seated and you can go comfortably. Maybe you can throw in some people there where they can stand, and you can make it up to let's say 70 people. Okay, after 70 people you can't add more people, right? You can't add more people. Only the limited capacity, that is the bearable amount for that bus. Same goes to the computers as well. You have limited resources, this amount of RAM, this amount of CPU, and you can cater. Let's say for within our system, we knows that okay, within that current limitations, we can without an issue we can cater 100 users. But all of a sudden, let's say we have 200 users coming, we have like double size. So we know for sure what will happen is the server is not able to handle that kind of users. Two things can happen. Either the server will crash. Okay, the server will crash because there are too many requests, memory is not enough, and people who are working with the system, they no longer will be able to work with that. So in that scenario, what will happen? Our system uh, will be flooded, and no one can get the service. The system will turn off. Otherwise, even if you try to turn it on, the same fate might come because we have exceeded the number of users that we can hold for the system. So that's going to be a tough thing that we need to handle. So in a scenario like that, if we can scale up, or we can say vertically scale the computational power of the machine, then what we can do is we can add more users on board, or we can handle more requests, we can do more computational time. Say for example, we can theoretically think if we can handle 100 users using 512 MB RAM and 1 CPU, if we double that, like 1 GB of RAM and 2 CPUs, maybe we can handle 200 people. Okay, that is like assumption that we can take. Sometimes it is not always the case. Sometimes even double every resource, we can't guarantee that it's gonna support. Like, at least for sure, we can add more users. Okay, we can add more users to the current working system, and they will be able to work within the system. But the problem is when we are scaling up, okay, when you're doing vertical scaling, when you're doing additional scaling to the computer, the hardware has certain limitations that we can go. Like if you are using a machine, if you are using a physical machine, like let's say you have a motherboard and everything set up, and there's a physical limitation a machine can go. Okay, it might support up to like 32 GB, and there will be like only one CPU supported, and it will have like 32, it will have like 16 cores. So there is a maximum limitation the machine, the hardware can go. Okay, so in this instance where we go to our maximum capacity of our hardware, what will happen? What is the next mechanism that we can do? What we can do afterwards? So in a scenario like that, the vertical scaling has reached its highest. Then there is there is nothing we can do in hardware level. But of course, when we are talking in the cloud era, right now, we have like virtual computers that we can build, right? So the if you use some cloud provider like Google Cloud, AWS, or something similar, there are machines where you will find that like, even if you have the right amount of money, you can build a machine which is somewhat similar to a supercomputer. Okay, you can create a machine which, I think there are like machines where are like really computation intensive things. Like you can have like 32 cores or 256 cores. You can rent such a machine when you're using a cloud provider like that, they are using special techniques within the data center to work with several machines and act as one. But in a normal situation where we are using our own hardware, you can do that, you can achieve that. It's gonna need some hardware specification to be worked with. So in general purpose, you won't find such a thing. So you can go to a maximum of what your hardware is limiting. So vertical scaling, or what we call scaling up, has a limitation. So if we are in the maximum of our hardware limitation, then there should be another way to scale it up even more. So that's where we call the horizontal scaling come in. So in horizontal scaling, what we can do is we can add more resources, not only by the hardware limitations, but we add another machine, or what we call an instance to it. So rather than working within one machine, we can have two machines now working within our application. So we have two machines that are working, and those two machines will have a combination of the computation power that we need, or maybe we can have isolated instances running on our machines. So for example, in a um, in normal softwares, okay, when we are developing, most of the time when you're experimenting or something like that, it is not the best practice, by the way, but you can do like your application, your database, and if you have a cache engine, all of those services can be run within the one single machine. Yes, that is possible. Right now, when we are developing our applications, we run our database in our machine, we run our front end, back end, everything in one single machine. That is doable. That is okay for development purposes. But when we are doing application development or application uh, for production, we do not recommend that kind of approach. Why? If for some reason the instance, the server that we are running tend to be faulty, or your hard disk get corrupted, you lose everything, your data, your program, everything will be lost for you. So in order to avoid such a catastrophe, what we can do is, okay, rather than running everything in one single machine, we have separate instances which are capable of handling um, separate services. For example, there can be a machine where you can run your database, and you can have a cache database or cache engine in a separate instance. Your application will be in a separate instance. So that's kind of mental mind is there, where you can have separate instances, separate nodes, where you can run your servers, linking those things via a network. You can work as a single instance. So that is also possible. And sometimes there are situations our application need more scaling up to be done. For instance, our application, okay, we have a database instance, a separate one, that is okay. We have an application that need to be um, scaled up. So we can scale up our application, but depending on the architecture that we are developing, depending on the architecture that we have developed the application, there are certain patterns we can scale up our application and scale down. So most of the time when we are developing such an application, like a small application, when we are starting a simple application, we would definitely go with something like monolithic application. Where, if you guys can remember, when we worked on the NT architecture, when we worked on the web application development, the API development that we did, we use the NT architecture. Okay, the India architecture, what we call as a monolithic application. But um, there are certain limitations with monolithic application, especially when it is coming to distributing the app or scaling up the application. So we will come across such scaling problems, and we will see how we can get over that. Okay, give me a minute, guys. I need to check on something first. So, what we are developing when we are developing an application, this is like the basic application architecture. We have what we call client, we have application, we have a database. This is what we call a classical monolithic application development. So when we want to scale up the application, what we'll do is we will have more instances of the app itself, like this one. We will have 2 or 3 instances. Two of them are running, and the database will be shared. So that is like the most common architecture of scaling up the monolithic application. Okay, that is like most common way of doing that. But it comes with several problems, like when we are scaling up these things, all the things within the application itself. For example, we can have a lot of functionality within an application. All those functionalities get replicated. Okay, so for example, if we talk e-commerce application, there can be accounting, inventory, shipping. All those things are gonna happen within, gonna happen within one single instance. And when we are scaling up, there will be accounting modules, inventory modules, and everything will be duplicated. Okay, the instance that we are referring in here will be duplicated. So all these services, all these functionalities, all these modules will be duplicated. But in a microservice architecture, what will happen is, rather than having these everything, the every feature, every module within one single application, one single service, we break it down. Okay, so if we have accounting module, what we will do is we have the accounting module some like this, and we have inventory module. All those services will be what we call will be break down into small services. Hence the term micro comes in. So small services, rather than having a huge big bulk of application service, we will have smaller service which is responding to which should be responding for events. So the advantage of having microservice is like when you are using microservice architecture, the database that we are using, we can use database per application. Okay, so um, um, so in a scenario like that, we can have in a scenario like that, what will happen is we can have separate database types even. For example, the account module that we are using can have a type of database X. That means we can have for accounting all the operations that we are doing. We can have SQL database. Give me that. So inventory, we can have like a NoSQL database. Okay, for shipping modules, we can have like a recommendation engine or caching engine. So we will have different use cases based on our application and application usage. based on our application, we can have uh, separate databases and it will optimize. So rather than depending every aspect of our application to a certain data type, we can have expert systems, expert database, expert application development. So that's going to help us a lot when we are working with certain module in our application. So that is an added advantage for us. And of course, you guys can see in paper, in when we are developing a microservice application like this, you guys will see it is easy. We will just have small services and we will do whatever we like this. No, it is not the case. It is like what we call is like the complexity of developing such a service is really high. Okay, monolithic application, you guys can see it was very straightforward. Okay, you don't need to know much of everything. You guys need to know how to find the database, inject it, then you can use it with the tiered architecture and so on and so forth. So really simple, really straightforward. But when it is coming to microservice, that is not the case. Microservice is really complex. Okay, that's why the microservice adoption is, unless you really know you are dealing with millions of users or you are dealing with a lot of users who need a real-time system, you won't be definitely not be developing a microservice. Okay, but the microservice architect is here and it is something you guys should know. That's why we are emphasizing this, and you guys know when and where to use microservices and where to use monolithic. Okay, most of the time, like 90% of your time, you guys will have a chance to work with a monolithic application if you're lucky enough, or you have the chance to work with microservice. That is also something possible. Okay, so working with a microservice, you should know certain things, especially there are certain terms, there are certain technologies. It's way more complicated. I can teach you guys or a full semester on microservice all along, but we'll try to keep it as much as compact as possible, so you guys know the basics, then you can expand your knowledge afterwards. Okay, so let's see how if you guys haven't followed these lecture slide, you can follow these along. I'll also share you guys video recording of these me explaining everything, so you guys can even watch that in a more detailed manner, so you guys can get an idea on the pros and cons and everything. So I'm not going to go through within this in here. I'm not going to go through all of these, but I will show you guys the implementation of this, and we'll try to understand what's going on. Okay, so in nutshell, we talked about monolithic application and why we need microservice applications. Okay, so microservice application really depending on communicating really shine on huge applications. And one thing that that is emphasizing on the microservice is service to service communication. That is really important. Okay, so let's say, for example, in a monolithic application, if the inventory module want to talk to accounting module, you just inject a service, or you have entire architecture, and you can call a certain layer Okay, let's say for service layer, you want to talk to from inventory module to accounting module. All you have to do is access the accounting module service layer. Then you can do direct communication with that. But the problem with microservices is that this service does not run it in the same machine or even the same network. Maybe those are in two different global regions. Accounting module may be in US region, while the inventory module may be in Europe region. That can happen. That is the beauty of microservice. You can deploy these things in various regions. So service to service communication, it is like what we call the pain point of communication handling. So there are certain ways that we can overcome this situation. So we can use different way of communicating with each other microservice. Okay, so in here in this application, we'll be exploring the service to service communication within microservice using the normal protocol, what we know as TCP protocol. Okay, that's like normal protocol that we are using day to day. So we'll be using TCP protocol to communicate with one or more microservice that we're going to be developing. Okay, so it's going to be pretty much simple, a simple application that we're going to be developing. So we will have two microservices, two small services, and we will try to communicate. So this, if you think this as this is something similar what we see in client server architecture. It is something similar, but only difference that we see in here, all these microservices are acting as one single instance. Okay, so this is providing all these services, all these microservices come together and perform one single task, or they are doing one job at a time. So by dividing those small functionalities into small services like microservices, what we try to achieve is we can have uh, certain scalability. We can have certain scalability. We can scale up any microservice instances that we like, and when we do that, we have scalability. We can overcome the scalability issues, and downtime is can be really less. And also one other thing is when we are deploying these things, the zero downtime. Okay, that is one of the most promising or most discussed term when we are talking about microservice, is that zero downtime. So since the services are replicated, okay, the microservices can be replicated, right? Not only breaking down into these services, but we can replicate one single service into multiple instances. So for example, the microservice that you find in here, which is highlighted in here, can have multiple instances. For some safekeeping, we can have 10 instances of these microservices, 5 instances of this microservice, and maybe 2 instances of microservices of this. So we have the zero downtime policies where if one microservice goes down, the other one will take over, and that kind of thing, and the load is balanced, something like that. So we will use basic HTTP, and we will develop small microservices that we'll be working with. Okay. So as I mentioned earlier, the microservice architecture is the most of the time when you are working with microservice applications, you will find a lot of information or a lot of support around frameworks like Spring Boot, which is in Java or Kotlin. Okay, so that is true. Like earlier on the market, like when the microservice architecture was getting more attraction, even it there is, but when all those things started, frameworks like Spring Boot and software companies or like streaming giants like Netflix, they have come up with bunch of solutions, some bunch of applications which will help us to develop microservices. Okay, but nowadays all the other frameworks, including Node.js ecosystem, Go, even PHP, any language that you are fond of, any framework that you are familiar with, you can find any amount of examples which we can set up a simple microservice architecture. So today we will be working with a simple NestJS application, which will help us to set up a very simple microservice, and we will do service-to-service communication, service-to-service microservice communication using TCP protocol. And by the way, TCP is not like the optimal way of doing service-to-service communication. It is the most easiest way. Okay, there are bunch of other high available transportation systems and failover systems which are available, including in this documentation that you will find here, especially with like frameworks, database like Redis, and queuing protocols like RabbitMQ, and streaming protocols like Kafka, and also gRCP. So these are like the most of the time you will find microservices which are running on either one of these three platforms. These are like the most reliable, as well as most of the time these are the industry leading service communication mechanisms. But for starters, we don't want to go we don't want to go into that much detail. What we'll do is we'll start simple with TCP. If time permits, we will go into some other transporter implementation. Okay, so right now we will use TCP. So get started. We will need to have the NestJS microservice package installed. First of all, we will create a simple Node.js application, at least in NestJS, and we will see how we can integrate the microservice architecture into this. Okay. All right. Give me a second while I open my application. Document project. This is going to be Linux. And let me share my screen once again. Okay, so I hope you guys can see my terminal as well. So within this section, what we'll do is we will create a simple application and try to share information. So in this application, I'll be using something called the NX tools or Laravel tools, which help me to develop application in a monolithic way. You don't need to know much about that, but if you're interested in, I can show you some other lectures that I have done, which will ease into NX and everything. But simply, It's just a tool that will generate or scaffold a simple NestJS application for us, and we can use that in our microservice development. So first thing that we need to do is we need to create something called um, a workspace. So in order to create a workspace, I would use npx create workspace latest command. Okay, so I will call this micro test. Okay, so what I'm going to do is I'm using the npx command, which is like a temporary npm. Using that, I will create a nx workspace with the latest version, and I will name my workspace as micro test. That is um, that is what it's going to create a simple workspace, and based on your application and everything, you will get something like this. So in this scenario, nx, this is something with nx. You can create a minimal project, or you can create a React, Vue, or Angular project. Right now, I'm interested in creating a Node project, and even with that, I will be using the framework NestJS. Okay, you can use NestJS CLI as well. That is okay, but I like to use NX tools. It's help me with a lot of things. And I would use I can use a standalone application. That means there will be only one application will be developed. But since we are developing a microservice, I am gonna need more than one. So I'm gonna choose integrated monorepos. So in using integrated monorepos, you can have multiple projects within one single workspace. That is good because in a microservice, you will probably develop several applications, and those application will be within something called monorepo. That means a single repository will be having those things. So rather than going to standalone, I would go to integrated monorepo. And what is the application name that they are asking? So I will go with micro tests. And would you like to create Docker files? I'm not interested in Docker files right now. And this is something called a distributed caching, which is coming from NX, which help us to build and develop faster. At this instance, we are not going to be using NX other capabilities. So I would say I don't need NX stuff with me anymore. So right now, basically what it does is it's creating and scaffolding an application for me. Then I can use the index related stuff, so I can create an application. Believe me, and also remember, when I'm creating this application, it is not a microservice application by default. It's going to be a simple monolithic application. We need to convert our application into what we call a microservice application. Okay. So by default, it's going to create a simple monolithic. We will convert that into a microservice. So while it is creating, let me open another tab and cd into the project framework micro test, and I will open using VS Code. So let me share it once again so you guys can see it. Let me share my screen, which is gonna be Visual Studio Code and Chrome and Terminal, just in case. Okay, so the project is still generating, but so we'll be having a Node.js, a simple Node.js application, which will generate most of the code. Right now, I think it is almost done. So anyone here have developed a Node.js application before? Raise your hand, please. If you have, okay, it shouldn't be like backend one. Also, anything like front end or something like that. Anyone have developed such application? Okay, so if you guys need more information with regarding generating front-end back-end application, I can show you guys some interesting pictures which will definitely help you guys as well. So ping me if you need any more information on that. Okay. So basically, I'll just walk through the highest level as much as possible within this application. So in Node.js application, we often find something called the package JSON. This is like where all the dependencies and everything is for this application is defined. So we have dependencies like NestJS core, Axios, and RxJS. That's kind of development dependencies for runtime and development time. And there are some dependencies only for development time. That means at the final build, these things will not be included. This will help us to develop the application, but not to run it in production mode. Okay, so these are the dependencies we have. And one special library that directory that we need to emphasize is this apps directory. Okay, as I mentioned, this is a mono application, mono repo based application. So all our applications within here will be within the apps directory, and you guys can remember we named the application as micro test. So we have the app under that, and also with the help of NX, you will have the micro test E2E. That means end-to-end testing is also generated for us. So that's easy for us. So we have micro test application under SRC. You will find the app, and you will find most simplest form of application, and that is going to be it's going to have something similar to NT architecture that we discussed. We will have a service, we will have a controller, and probably this thing does not have a repository right now. But something called app module, which combine all these things to one single module. So we have the app module to take care of that. Okay, so the app module is like the starting point for application. It's the main module that we're going to load. But when we are working with microservice application, we'll probably get rid of these things and use something new. Okay. So we can just test this and see whether it is working. So what I'll do is I'll go to the NX, at least my terminal, and I can say NX serve, and I can say micro test. Okay, that is the service that I'm gonna test. And if I am successful, I will get a localhost 3000 and API endpoint, which I can just simply go and visit, and it's gonna give me a simple hello API message for me. Okay, that's simplest form of developing this application. But right now, what we're gonna do is we will not be using this monolithic application. We will convert this into microservice application. Probably we will get rid of most of the modules that you will find in here. Okay, first thing first, let's go back to the application. Another thing that you need to do is we need to install the NestJS microservice package. That means normally, as I mentioned earlier, when we are working with application, we will get a monolithic application. Okay, in order to get the microservice capabilities, we need to add this package into our application. So I will add that one as well. So I will be installing NestJS microservice package in my project. Let's do that. I'll say copy this within my terminal. Let me terminate this one. I would say npm install save NestJS microservices. So by doing that, I'll get extra capabilities where I can run, where I can start a microservice. Okay. So while it is installing, I will go to the next section, probably in here. So next thing that we need to do is, you guys can see the bootstrap method. Right now what we have is create method right in here in the main.js. So we have global prefix and everything, and it is starting. So I'll just comment these things out, and I'll try to get an idea on this first. So we have Nest factory, and rather than create, we have a method called create microservice. And we can have the microservice option type. Okay, these are the options that we're going to be following along. And we will provide an app module, and we will select the transporter as TCP, and we will wait and listen. So basically what we are saying is, we are creating a microservice and we are using TCP as our transport layer. We'll see what are the other options that NestJS provide. Right now, I'm going to be creating the basics. So I need to import these microservice options. So I'll add the import in here, click on the button and get the blue bulb icon here, and you can import the update sections. So right now, what we get is a basic application or simple microservice that we have created. In the microservice, the transport layer is TCP. If you erase this along and put a dot in here, you guys can see what are the other options for the transport layer. And as I mentioned earlier, there are like most common ones like gRCP, Kafka, MQTT, and Nets and Redis. Okay, so we will be not using those fancy ones, but we will start something with baby steps. We'll use TCP. All right. So once we have created our application and app listen, we'll start our microservice. Let's try to run it once again using the same command. NXserve microtest. So NXserve command will serve the application. Which application? Microtest application. There are two applications, if you can remember, microtest and microtest end-to-end. We are interested in microtest, so we will run that application. Okay. So so it's saying that starting Nest application, app module dependencies initialized, Nest microservice successfully started. That means this microservice is run well and up and running. Okay, so we have this small service developed, and it is running within the machine itself. So let's see what are the things, how we communicate with each other, how we can create another service and get to interact with this microservice, and so on and so forth. Okay, let's go on the tutorial. So by default, it is TCP and options. We will skip these things. We will stick to the basic. For the transporters, MQT, if you like, since we are using TCP, we do not need big configuration changes. But if you are using such other services, such as what we call Redis, MQTT, or something like that, there are special servers that we need to run. If you are using Redis, then we have to run a Redis service, and we need to inform, okay, this is the Redis service that we are using to make the communication. So these options, the option that we give they have other customizations that we need to do. Right now, we are not focusing on that. We'll just simply stick to TCP, so we do not have to do any other any other configuration changes. Okay, so so microservice in here we need to learn these two things. Okay, the patterns that we are going to be learning. So this is one of the most important things. So pay close attention. What are the patterns that you will see in microservices and how we can work with this. So so microservice basically the communication patterns happens in common most of the time, either events based or message based. Okay, so we can send messages and we can get a response, and there are some other things what we call events. So certain event happens, and based on that event, someone react on that. Okay, so we have the option to either use the messaging or we can use either message based systems or event based system. Okay, uh, so anyhow when we are using anyhow we are using these patterns, the NestJS framework is what do you call generous enough to do most of the heavy lifting for us. Okay, so when we are sending a message, when we are listening to an event, so NestJS will definitely help us identifying those things, and if it is a message, who is the sender, who is the receiver, and we can consume those things, and we can handle. With the event base, yes, we will send certain events, and based on those events, who will react and who what are the response for that events, it will also be automatically done for us. So we will look into these two patterns and try to make sense of and where both messaging and events shine on each other. Okay, so they sometimes we can mix it, but there are specific use cases that we can use that will make more sense in some applications. Okay, so first thing we will use is the normally 99% of the time we are what do you call familiar with patterns like request and response. So the request response is like when you need to exchange pattern between various exchange services. So normally, if you guys can remember, when we created the REST API, normal monolithic application REST API, so that is something comes under request response. So we need to exchange some data from one another to another. Okay, so we have um, uh, uh, we have some things like we send a request, and based on the request, the server will give us a response, and we will consume that response and work. Okay, that is like the basic request response application architecture. And when we are working with TCP and some basic structure, so we will be using something called like the request response or request response pattern that we are using. So other streaming or something like that, we do not know whether the response will come right after we do a request. The response might not come easy as soon as we do the thing. So in such a scenario, we can use something like Kafka and everything, Kafka and net streaming to resolve that. So they basically that kind of solution We can use the streaming based or event based one. So we will see these two in action, then we'll try to understand. So basically, we have request and response. As soon as we request something, we will get a response. And there's another case where we do a request, but the response is not guaranteed at that moment. Okay, it is going to be event driven. Like means I'll ask something. Okay, the when I request something, it will say, okay, we received your request. We will inform you the response later on. So in a scenario like that, that's where streaming and event based is working perfectly, where you do a request and you will get an acknowledgement, okay, that we have received your request, we will get back to you. But in a request response, that is not the case. We request something, okay. Once the request is made, you will get a response as not. I mean, as you do the request, it will do the processing, and once the processing is done, you will get a response. It is not gonna say, okay, we received your request. Please wait. We are working on it. And once the computation is done, you will get back the response. Okay. So two different scenarios. One with immediate response. The other one is we will get back to you. Okay. We'll see what are the things that we can do such a thing. So in order to create request response message type, there are two logical channels that we need to use. Okay, so that one is accepting the request, and other one is respond to that request. So we will create such application where you do a request and the other person is giving you the response to that request. Okay. So let's see how NestJS or any other framework that supports these things. So as I mentioned earlier, NestJS is just one example that I'm using in here. You can use any other framework which has the similar capabilities. As I mentioned earlier, um, Java based microservices were like really popular at the starting of microservice era, like way 5-6 years ago. So in Java and frameworks or like supporting frameworks like Netflix based or Netflix has huge amount of supporting libraries for these things. So if you're using Netflix OSS, we call the stack Netflix OSS, Netflix open source softwares. So in there, you will find something similar to request response style messaging. If you want to do request response based styling, microservice communication, in Java and Netflix stack, you will find something called Fame client. Okay, you will have the Fame client, which you can do HTTP style request and response, request response. Um, request and response time application communications. Okay, so in here we have we don't need to have such third party one. NestJS has its own built-in TCP communication. We can utilize that in here. Okay, so we can use the message in here. We can use a message pattern decorator, which will respond to our request. Okay, so um, this is something that you guys we are familiar with. If you guys can remember, in NT architecture, we use the controller annotation in Java classes. But in here, it's the same thing, but something with something a little bit different. So we annotate our service, our entry point as controller. Then what we will have is this message pattern. Okay, the message pattern which indicate what is if you take the example of REST API, this is like the endpoint. Okay, endpoint. So the message pattern, it will be something what we call a command. So if somebody asks the request to execute the sum command, the message pattern, this method will be responsible for accumulating the this message will be responsible for giving back us the data that we need. Okay, so the message pattern is something like the name that we have given here is going to be something similar to REST endpoints. And when we want to call, if someone calls this sum method, the accumulated method, the function that we have in here will be executed. And you guys can see it's simply asking an array of numbers which we have defined as data in here, and accumulating or the sum will just take the summation of the numbers of element and return one single number. So this microservice is pretty simple. It's called math controller. The math controller will return a summation. The command that get executed, the command that is responding to this controller, and this is accumulate function, is the command sum. Okay, the sum command should be invoked and the data should be provided. When that happens, this microservice get activated. So let's see, we'll simply adapt the same pattern in here. So I'll copy this method right now, and you guys can see that in microservice test, okay, and I will have the main.ts. Within here, we are using the app module, where it is like a common place where we gather all the services and controllers. So we have a controller in here. Since I'm not using that one, I will utilize that controller to do the things. So in here we had a service and everything like normal NT architecture. Right now, we can use the NT application stuff, but since we have discussed NT, we do not. I will not follow that pattern right now. Simply what I am doing is within the app controller, I will have a command called sum. Somebody calls this and I will get a list of data and I will submit. I'll just simply take the summation of those numbers and I will return it. Okay. So the app module is where we connect those things. The service is actually no longer in use. Even we can delete this because I did not define a service layer. You can do that like what we did in the architecture. For this demonstration, I'll do the logical business logic within the controller, which is bad by the way, but for demonstration purposes, I hope this is understand for you guys and you can implement a service layer if you like. Okay. All right, that is the simplest form of having a controller right now. So any questions up until this? We just did very small things. We created a simple microservice application and we registered the app module. Within the app module, we have the controller and a controller, which will respond to the command sum. If somebody is asking for the command sum and provide us the data, this microservice will return the information, the data, it will take the data, calculate the sum and return. So that is the basic thing that we have created within this simple microservice. Any questions up until this, guys? Okay. Right. So in here, this is something related to the stack that we are using. So the accumulate function that we see in here, we can either use direct communication, that means synchronous value returns, or we can do asynchronous value returns. That is totally doable. In this scenario, the application, the accumulate function that we are using here is not using any asynchronous operations, such as, say for instance, we want to talk to the database and the database is giving us some details or something like that. In a scenario like that, this function will have to wait until the database operations are done. Okay, so that means we are waiting on some resource to be completed. In a scenario like that, this function probably will be something like an async function that indicates there is some asynchronous operation going within the function. We have to make sure that async functions are completed in order to get there. Right now we do not have, but we can have asynchronous functions. If you are doing asynchronous function, make sure we need to have the async keyword in here, and whatever we need to return, it should be something wrapped around a promise. Okay, that is something external. If you are using some asynchronous operators, probably you have to use promise. If you do not, you can use synchronously, like we had earlier on. So there are other things is like observable patterns. I think we discussed a little bit on this in our new application, if I'm not mistaken. But in a sense, like we have we have another way of doing this is the promise. The promise way is like what we call asynchronous operations. That means, so let me go from the beginning. We have synchronous, then we have asynchronous, and the third one that we are talking in here is what we call stream. Okay, so we have three options: synchronous, asynchronous, and stream. So you guys have a look. What are the difference? Synchronously, asynchronously, and streaming. So if you use synchronously, the earlier response, something like this would do. If you have asynchronous response, you have to have async keyword and return it as a promise. But if you choose to stream the data, that means we are not done with the data responding. We are still sending as a stream. Then we can use something called observable, something like this. Okay, then we have to create observables out of it, and using that we can respond to our application. Okay, and this is three ways of returning values: synchronously, asynchronously, and streamable. So you guys can see the message pattern is remain the same. Okay, the message pattern is remain the same. The command will be the same. The response type, it's going to be different. So it can be either observable, either a promise, or a simple synchronous number. Okay, depending on your use case, you can have either one of these mechanisms or methods in order to get things done. All right, that is like what we call request response. Okay, we do a request and we get a response, either one of these three ways: synchronously, asynchronously, or stream. And with the event base, as I mentioned earlier, event is something a little bit different than a request response one. So we request something from the server, some from the service. I say, hey, we need this to be done. We are doing that request. Once the request is made, okay, you will get what you call an acknowledgement. Acknowledgement in the sense, okay, we received the request. sorry, we receive the request, then we'll see what we can do. Okay. Oh, I mean, it's not like we will not get back to you. At least we will say, okay, we received your request, we will work on it, and we will, if it is success, we will notify. If it is fail, we will also notify. That's kind of thing. So event based, we have we will say these kind of events are emitted, and that event will be processed by someone else. Okay. um, so this is used in most of the time where you can't have we can have a specific response at a given time, but a service will act upon on such event is received. For example, if we have something like um, if we have something like in a real world scenario, for example, let's say we developed a ride sharing application. Okay, we have developed a ride sharing application. So when there will be certain events within that system, right? What are the events? Like, by generally looking at out of it, there can be simple events such as the ride has started. Okay, the ride has started is an event that happens within the context of the execution. And there can be events such as by by midway for some reason the the uh, the event by the mid of the journey, maybe the rider will cancel the trip. Okay, for some reason they can do that, or the passenger or the driver can cancel the ride. And there can be positive scenarios like the ride has ended. Okay, so each of these events, okay, will have different execution paths. If the start of if the event application has started, then what will happen? We can start few things, especially if that event has occurred. We can say, okay, we should start monitoring the movement of the vehicle. We should monitor the upcoming traffic. So based on the executed event, we can start several other processes. Okay, as I mentioned earlier, when the event is fired for starting the ride, uh, a microservice or a party will be responsible for tracking the responsible for tracking the movements of the vehicle. Another service or another instance will be responsible for monitoring the up ahead traffic and try to come up with the best route. Another microservice or another service will be responsible for, okay, I received the ride started event. So based on that, I should start calculating the payments. Like, literally, if I go 10 meters by for that 10 meters, we should start the calculation, because it's not like we are calculating for 10 kilometers. Most of the ride hailing applications, they calculate other things, such as if I start calculating now, and if I wait 2 minutes, then I will be charged for the waiting 2 minutes. Okay, and if I go another 8 minutes, then another 8 minutes riding time will be charged. So based on the ride start event, I'm not I'm not specifically asking other service to give me a response, but based on that event, others will start reacting. And you guys can see there are like terminations events. Like if I say, okay, at the end, at the middle, we are terminating. So if I say the ride is terminated, either cancelled by the user or cancelled by the driver, or simply it is ended. The destination is reached. There is no longer needed to continue their ride. So we can dispatch another event saying, okay, this the ride has come to an end, or the trip has now terminated. So based on that, other events will react. Okay, if if the event is ended, no longer we need to monitor the traffic. Yes, that is true. And we no longer want to do the calculation of the payments. We can just calculate the final value, or we can say, okay, we have been 2 minutes waiting, 5 minutes traveling, another 10 minutes waiting. So we'll come up with this, the summation of the application. Some of the right. So that kind of event, the termination event, will again fire certain chain of events. Okay, so based on those events, we can react. Okay, that is the event-based driven system mindset. So rather than we are saying okay, the trip has ended, now calculate the total amount, stop monitoring, and stop watching traffic. Rather than calling those services one by one, each by each, we will just simply say the ride has entered. uh, Based on that event, you do your calculations. Okay, so it is like publicly announcing or publicly saying this has happened, do what you need to do in order to continue. That's kind of mindset is in event-based systems. So when we are creating something like that, it is something that is in here. In order to get the request and response, we had the message pattern. So the message pattern, what will you do? It will somebody will request and it will do the calculation. In event-based system, it will have an event pattern. Okay, it will act upon user created event. If somebody says, okay, now user has created, this method will act upon it. Okay, so it is something similar that we discussed on the ride hailing application, where the trip has started, trip has ended. Okay, not all the events going to be listening by the same event pattern. Several different events will have different listeners. So the event pattern that it's going to handle in here is only the user create event. Okay, there can be a separate event which is for user deleted or user logout, that's kind of thing. Okay, based on that event, when that event has occurred, the certain things will happen within this function. Okay, so two things: event based and request response based. If you are using request response based, we are using message pattern like we did in here. If you're using event based, we have event patterns. Okay, and remember, this is something specific to this use case. That means this is something you will find within NestJS, but you will find the similar implementation on different frameworks. So try to translate these things according to your needs. Okay, right now we will just learn the theory and apply it in either one of these things. It's not possible to apply everything in each and every framework. It's out of the scope. But since we have the building blocks, you guys can easily adapt. Okay. Okay. So there are like more sophisticated decorators. Will not go to these things because it's basically depending on use cases of like other transportation patterns. So we do not need that at this time. Okay, but if you need, you can work on those things in later on. So so we have two way of rest way of two patterns where we can act upon. One is message based, which will give like a client request and response. The other one is event based, which will act upon something happens. But the other spectrum or other part of this application is the client interface. In this scenario, we are talking not a typical client, a client which is like if you take the NT architecture where we developed a REST API. So the client will be a web browser or a REST client or something like that. But in this scenario, the client is also going to be another service, another microservice will be responsible, will be doing the request. Okay, the client in this scenario, what we are talking in here, is going to be another service. Okay, so so we'll need another service which is going to be on the type of another application. Okay, the application will have to work as the same way that we have worked in this application. Okay, so we can think the we can think in an NestJS context, the application exchange happens something called the client proxy method. We will get into the client proxy method in a while. So we use the send method for request and response message type of handling, and emit for event driven or the what we see in the event driven application. So we have two methods that we can request. So in order to invoke an event, we use the emit. In order to invoke a message or response request, we use the send method. So that is like two different methods that we need to use in order to invoke those things. Okay, so we need to make sure that we are doing a request. Okay, we are doing a request. So how do we find the microservice that we need to accept? So we can have multiple methods in order to do that. So how are we gonna do? How are we gonna know? Okay, that there can be multiple microservices happening in the same system. So how do we know that which microservice to be called? How do we identify each and every microservices within our application? As I mentioned earlier, there can be multiple services. Okay, each and every service should communicate with each other. But the problem is, how do we know where to call, what to call? In that scenario, where we come to a place where we will use the register method and the name for that application. So whenever we are registering a new application, we have to register with a name. So by using that name, we can talk to each other. So it's like basically we are giving a name for the microservice. So let's say we want to call from microservice A to B. So we need to say, okay, I am microservice A, I am microservice B, and I want to talk to microservice B using event based or request response based. So we need to name them. So the naming happens in the client module section. Okay. So you guys can see a simple client module registration. That means I am registering this service as match service. Okay. So within the microservice itself, if somebody is identifying as, okay, I am match service, so they are referring to the match service name that they have given. Okay. So the other services can have different names, and all those different names, by using that name, you can call either a request or an event. Okay. So make sure we give a name for the services. Otherwise, what will happen? They don't know what to contact, which service to be contacted. So in order to know which service is contacted, we should give them a name. All right. So we will have this client module registration within our application. Right now, I will go to the app module section in here, and you guys can see it is happening in the import sections. I'll add the import section right around here. Make sure we import the client module from NestJS microservice and transport it to TCP. Okay, so we registered this micro test application as match service. You can name it as much as name permits. Okay, so now we are calling this as match service. Okay, since the service is giving us a message pattern of accumulating data, we are simply doing some math calculations. So we are calling this module as math service, this service as math service. Okay, you can name it whatever you like, but remember, in order to communicate with this service, this name is used. So this is like simplest fine definition, but if you use tech stack like Spring Boot and Java, you will have the same similar problems, similar things. So you need to name these variables. So whenever you are creating an application, the application will be named. The name, the service itself will be named. You can give a name within your application, and after onwards, when the application is running, we are no longer communicating with anything like IP address or something like that. We are simply communicating using this service name. Okay, so in Spring and Spring ecosystem, you will need some things like service register, which keep a track of all the names and all the instances of this application. Right now, we do not have such a requirement. We do not need, but we will see how a microservice will work and everything by communicating with these things. Okay, so now simplicity, we have the simplest form of microservice, and we have named it as match service. Cool. So any questions up until this, guys? Any questions in this naming convention and everything? Okay, from now. Okay, let's continue. So whenever want to communicate with this service, so this is the name service that we have. Say for instance, within this microservice environment, I need to call this then I can use the injector token or the name token that we have find in here in order to talk with that application. So it is a implementation of client proxy. All you have to do is if another client, say for instance, other than Met service, needs to talk to the Met service, all they have to do is inject and use the client proxy method. We'll see this in action and see how we can use that. So client modules from my service, say config service, how to configure client application. So in this scenario, we have to use what we call the provider in order to use the proxy instance. So we will use the config service and the service options and everything. Right now, we will just leave it as it is. We will just assume that this is this is configuration where we are doing all the client registration within our application. As I mentioned earlier, in Java ecosystem, we have something called service registry. All these services should go and register in a registry, something like Eureka or Consul. Okay, but in here we will be using simple configuration server. So we will use this config server, which is like built into the application, so it will be really easy for us to use. So do not worry about these configurations. Just we will have this provided within our application. If somebody is asking for Met service, we will be using the client proxy to get hold of that. Okay, right. And the last option is when we want to call the client, especially from a third party especially from outside of the microservice. So we'll be using this injection token like this. So it will be we will be able to talk to the other service directly. Okay, we will see this in action right now. We will have a client, the type will be TCP, and we will use the client proxy. And and make sure when we are using this client proxy, we need to make the quick connection between the two clients. So once the application has bootstrap, that means that when the application is started in, we need to make the connection to the client. That means the Met service and the calling service, whatever the end client service, need to be in sync with each other. That means we need to establish a connection within each other. So we need to call the establish method or connection method right after the application is bootstrapped. Okay, we'll have this thing in here. So make sure that is also done. And the last most thing that we need to do is when we want to invoke the service. So we had the application. We had created the microservice, which will take a set of numbers, and it will give result back. Now we need to make sure we need to call that and get our result back. So you guys can see there are two things in order to do a microservice call. We are calling from one service to another. So there are two things that we need. First one is the pattern. Okay, which method that we're going to be calling. As you guys can assume that within one single microservice, there can be a lot of patterns. Okay, we can't assume only one service is going to be there. So like in here we have accumulate function that will accumulate the numbers. There can be subtraction or some other mathematical operations. That kind of thing can happen. So we need to make sure what is the command that we need to execute when we do the microservice request. So whenever we are invoking, this command should be executed. You can see the command is sum. As you guys can clearly remember, the message pattern we had earlier on, the same command is used. The command is sum. Okay, so we have to use the same command in order to execute this method. Okay, and see the payload in here. Whenever we want to call the accumulate function, we are sending an array of numbers which we identify within this machine, within this method as data. So in order to call, we should send number of at least numbers array, and that number array should be sent upon. Okay, so you guys can see we are next thing that we need to do is invoke the client. And remember, we have connected our client using this connect transport method. Okay, that's how we know we have used the connection proxy. That means we have a connection to this one, but the registration happens in here as well. So make sure we have that as well. Now you can use the constructor based injection, or you can use the annotation based one. I would probably go with something like constructor injection, which is similar, which is familiar to me, but you can use the annotation based one as well. Okay, that is up to you. Which one, either one of the injection, we should get instance. We should get instance of the client in order to send. So we are communicating from outside service to the met service. So the met service is now binded using this client. Okay, so we will send the command. As you guys can remember, since that is a request pattern, request and response based one, we need to use the send command. If you need to send an event, we should use the emit command. Right now we are using the send command. So we are saying specifically in here we are using send command to get a request and response, and this is the pattern that we want to talk, and this is the payload that we want to talk, and what is the expected outcome of the method call. Once we call this method, it's gonna give me a number, because when I give certain numbers, I should get in return as one single number. So this is the expected return time. Okay, so this is how we do a service to service call. And make sure that correct type is used. If it is request response, it's going to be a send. If it is an event based one, it's going to be an emit. Okay, so publishing an event, we use this one as like not an event but a request response. If it is event, it's going to be something like client emit, and what is the event that we are interested in, and what is the payload for that. Okay, that is the same thing. You can do it in one liner in here as well. Okay, and it can be done something like in here as well. We'll see both of these in action once we create our application. Okay, so we think about scopes, which is something related to application, and some things like timeouts, which will handle how many time that you will be waiting, or how much longer that you will wait if it is an request response. So I can say after 500 seconds, I'm not gonna listen to this. If within 500 milliseconds, if I'm not getting this, if I'm not getting a response, I'm no longer listening to this. Okay, so those are like timeouts and everything. So we do not need to work on those things right now. So what we'll do is, so we have the Met service around here. Um, next thing that we need to do is we need to create another service and do the exact calling. Okay, so we have one micro test application which we name as Math service. Now we need to call this Math service from another service. Let's see that in action and we can get an idea on what we are doing in here. So what I need to do is, this is like the server, this is the Math service. I will call, I will have another application which will call this service. Okay, I can do the both is, that means two of these things can message with each other, but I'll show one way so you guys can do the bidirectional if you want. So let me create another application in here. So how can I create a new application? I can go to NestJenerate. Okay, if you're new, you can install the NX command line utilities, and you will get the NestJenerate commands. In here, you can create another application. Okay, it's like something out of this one here. So I will create an NX NX nest, which will create a new NestJS application. Okay, remember this one, this command, NX nest. That means I'm going to create another nest application, and I'm gonna call, I will call this application as micro client. Okay, so we have micro test, which is our service. Then we will have micro client in here, and it will create a simple service for us. I'll generate it. So you guys can see I have created another service, a simple service, which is called micro client. Okay, and my intention is, my target is, I have a microservice call in here. We call that one as Math service, and we have a micro client which is also going to be a microservice. Okay, so my intention is, I will call from micro client. I will call the micro client from within the micro client. I will call the micro test service. Okay, so this will be client, micro client will be the client, micro test will be the service that we want to call. Okay, so micro client, we'll probably it can be a normal REST API, a normal application, but this is going to be a microservice. Okay, this is going to be a microservice, but the client, it can be a normal monolithic application, or it can be also another microservice application depending on the use case. Right now I will just leave it as it is. So in order to connect the client, we need to get hold of the client proxy. Okay, we need to get hold on the client proxy. So we will do that. Give me a few seconds. Let me create the client proxy in here. I'll create a client proxy in here. So I will go to the client itself and go to app service. So the app service will simply return a hello API. Maybe I can return a value from the microservice itself. So I will inject the command and the client proxy to my application. That means within the client application, I'm going to be calling the Met service, and I'll be using the client proxy. Okay, let's see this. This will probably fall. We might need to do. This is not needed if you're hard coded things. And this is another way of injecting the client proxy. What we need to do is to okay, we'll send the message in here. So what we'll do is we will use this code snippet, and rather than return it back, I will const queue. So what this piece of code is gonna do? It's gonna call the Met service. Okay, it's gonna call the Met service, and we will get the accumulated value rather than showing the hello world API. I will say accumulated values. So I will say ACC, sorry, and ACC. So in the message, I will say ACC accumulated value. So we have the micro client, okay, and we have the service. Now I need to call the I will do a simple REST call. The simple REST call will just have the NestJS create factory, and the app module will be followed along. But the problem is, definitely we'll get into a problem. We can't have the we don't know this, as this is a separate microservice. There is no connection. The client, even though we have defined our client proxy in here, we do not know where to find the application itself. So we probably will need to register in here, but first we will let it fall and see what happens. So we have a Met service or micro test client within our application, which will start our microservice application using the app module and the transportation layer as TCP. So let's start that one first. So it will be simplest command. So in Excel micro test. So we are launching our microservice. This one, micro test, will be launched. Okay, let's see whether we have any errors. Okay, no errors found. Now what we need to do is we need to run the micro client. So what we can do is we can start another terminal, and I will run nxserve micro client. Okay. So when I'm doing that, it's giving me an error. So it is complaining that, okay, the argument met service, it is not known to us. We don't know what you are talking about met service. Okay, in here, the micro client, we have the met service in here. We are saying, okay, inject met service. We are saying we need to have met service, but the application, the main.ts, the client application, micro client application, have no clue about what you understand, what do you mean by met service. We do not have a clue. That's because the application, the monolithic application, have no clue about the running microservice. There is no connection. In here, in the micro test, we have defined the microservice within the using Nest microservice and microservice options. We provide the module and transportation layer, but for the client, we haven't done such a thing. So what we can do is we can also mark this one rather than create application. We will create this one as a create microservice application. And what we need to do is we need what's that? Give me a second, guys. Okay, so in here we have to let it be, and the thing is when we do the app service and everything, we need to say client proxy. What is the met service is all about. So what we can do is simply go to app module, and we have a place where we call providers. Let me do the coding first, then I can do the okay, I have the providers in here. Within here, I will define a provider for our net service. Provide net service, and we will say use factory. This is a factory. I can say I don't need any injection happening right now. And I can say return client proxy factory create options transport TCP. Okay, so right now what I'm doing is rather than converting this into another microservice, I will keep this one as a simple monolithic application or an endpoint per se. Now we need to communicate with the, we need to know about the client proxy, right? The client proxy and the met service. So in order to do that, we say, okay, we are injecting the met service. how do we find the met service? How do we know what is the met service that we're gonna do? So simplest thing that we can do is we define a provider for that. Okay, let's format that. Okay, so let's create a provider for that. So the provider that we're gonna provide is met service. It's the same name that we use in the injection pattern in here. And we will be using a client proxy factory. Okay, this is where the magic happens, where we connect the two places, and we will create a connection to the met service in terms of the TCP protocol. Okay, we will use the TCP protocol in order to inject this one. So we have a connection to the application, to the microservice, at least in here, using the client proxy. And we know where to find using what is the transportation layer that we're going to be using. It's going to be TCP. Since you guys can remember, the micro test, the service actually, it is also using the transport layer TCP, so we can communicate in the same layer. So make sure that you can't have cross transportation layers. One is in TCP, one is GCP. That is not gonna work. Or both of these communication should be within one single transportation layer. Okay. So what we'll do is we will just do a localhost API and see whether we get some result. So it should communicate with app service. Oops. This is wrong. Client app service. Now it should have a connection to the proxy, and payload is going to be 123. This is something like hard coded. The message we should get is the accumulated values. Right now, service to service communication is not working as expected. Let's debug this. That is so. Okay, let's see if it's not working. Localhost 3000 /API. Seems to be wrong with the server. The communication errors, that means the service is not working. The communication, I mean, we have defined the met service and we have defined the transport layer. For some reason, it is not connecting to each other. That's why it is not starting in here. Even though the server starts, the two microservices are not communicating. Let me restart the microtest once again, the server. Okay. We get something like object in here. I think the value is coming again. Seems to be some issue with the serialization. What I'll do is I'll try to print it out first. Then we'll see whether this value is returning. Or let me check the client send. Did I make it asynchronous? Yes, this is asynchronous. I'll remove the asynchronous layer first, see whether it is working synchronously. 2000 API. Um, They're doing the call, but I think there is, if I terminate that, I will get a response. Something is wrong. Let's debug it. So first thing is, let's see what's coming in here. Send command. It's gonna send an observer, right? Is the result? It's gonna be an observer result. Okay, probably I'm doing something silly in here. So let me do first one thing. I'll just I'll have this one return this message. I'll say okay in here, but in here I'll say aq.subscribe, and I will get the value. Format the code, and let's see. We'll start the microservice. We'll start the client. Okay, both are in good shape. Let me check. Still not coming. Connection closed or connection closed. That means microservice, I terminated it. Client send. Once I'm sending it, should get an value. Send. Let me run the client again. Client is running. Not sure the request is coming here. What I'll do is I will put some log message within the control itself. So if I get a message from the server, I will get some information, message pattern received or something like that. Okay, and microservice is restarted. Okay, I'll start it once again. And I will request from here. And if the microservice get the values, it should print out in here. Unfortunately, it's not. Okay, the connection is still flaky. That means this configuration that we are doing is not working as expected. That means the Mets service, the client proxy, it is not working as expected. What is the wrong thing that I am doing? Let me double check. Mm. Module register. My proxy factory, did I do something wrong? Oh, let's see. Whether we can get it done. Oh, I think I need more configuration maybe. Give me a second, I might miss something. Okay, think probably I forgot to do more configuration in here. The main service. I need to provide some options. Host. It's going to be abstract 0.0.0. Provide port. Let's say 88. Formatted format. And I'll some options in module transport here and option human. Let's see. Did I microservice started? Service started. Yeah. So it was like a misconfiguration. So one thing I forgot is like when I'm creating the service, the microservice test, I need to define few additional things like where the application is going to run and the host, the port that is going to run. Okay, that is one thing I forgot to mention. So that's I have added in the microservice, the Maths microservice in here. The host is 000 with indicate the local host, and port is going to be 8080. That means this microservice will be running on port 8080. Otherwise, there is no way to communicate with this. And the same goes in here. The same goes in here. The application it is using. The provider where we need to say the client proxy, where we can find the client proxy that we have done it in here. So we will say if you are looking for Math service will be a TCP transport service which will be running on the same configuration. It's going to be in the local host and will be running on port 88. So that is simply basically saying where to find the Math service. And what I have done is I have called the Math service using this client, and I have shown the value in log. You guys can see it is showing 6 separate sixes in here. So 1 plus 2 plus 3 is 6. So that is calling the service and it is getting back me the details. Right now, what I'll do is I'll return this one as the message. So I will say return return q dot pipe dot map. So you guys do not need to know much about these things, but it's going to transform the message and whatever the value I got, let's say total. So I can simply say I can say total, and I will delete this, and I have to put this in format document, message observable message number. I should remove the return type. Hope the controller is accepting that one as well. Let's go to the micro client controller. Yeah, it is not complaining. So what I'll do is I'll refresh. You guys can see it is giving me the result 6. If I go in here, the app service, the request that I'm going to do is I'm going to add 4 in here as well. And hit a refresh. I'll get the message 10 back. So right now, what we are doing is we are calling the Math service, and the service is responsible for sending the response, and I'm going to return it back to the service as a message and the total to be calculated. So it's that simple. This is going to be easiest form of application development, microservice in this scenario. So I'll do a quick recap so you guys can remember 2 things. So we have a micro test, which is the microservice responsible for doing the calculation. We have micro client, which will be requesting and showing the detail. So in micro test, we created a microservice using the create microservice mechanism, create microservice value, and we use the transportation server TCP, and it will be running on local host port 88. That is the simplest form. And it will have one single controller, which is going to be request response. That's why it is annotated in message pattern. And the command, it is sum. And it is expecting a data of array of numbers. And once the numbers are done, you will get the summation back. Okay, that is the simplest microservice. And in order to call that microservice, we have a micro client, and it's going to be a simple monolithic application. It's not going to be a microservice in here, but we need to make the communication happens. The client should know about the service. That means it should know about the micro test Math service. So in order to do that, we are using something called a provider. Okay, we give, okay, if somebody is asking for Math service, and it is going to be a TCP transportation, and it will run on localhost port 8080. And we are asking that details in app service. So somebody is in Math service, we ask Okay, what do you understand by math service? And we know since we have configured that, we know, okay, math service is the microservice which is running on port 8080 in localhost, and it has a command called sum, and that command is accepting, that method is accepting array of numbers. Once we call that, or once we send a message, rather than we are doing an event one, we are sending a request. Once we send the request, the pattern is the command that we are executing, and the payload is what are the values. It will send an observable, that means a stream of values, and I convert it in and show it in the browser. So in the browser, I'll simply see the accumulated numbers, and as you can see in here, since it is hard coded, the values summation from 1 to 4 will be 10, and I will receive that back. Okay. So that is like basic microservice implementation. So the benefit in here, the benefit in this application, this kind of application, is that we can run the micro test in another service, another not in our application, within the network, within the region, whatever. As long as we know how to communicate from the client, you guys can see the client has information about the other microservice. So as long as we know the microservice that we need to communicate, then we can do communication and work with that. So we are using TCP here, but we can use any other client protocol, like not transportation protocol like GCP and everything, but it requires a bit of configuration. So make sure we do that if you are using something like that. So that is the two part of client and service. And since the micro client and micro test can be separated into different instances, you can scale up horizontally. The horizontal scale will happen, and you can have two services running on two different machines and communicate with each other and do the things. It won't like drop down. It won't uh, it won't make any scalable issues if sometimes. So the other in another lecture, we will see how we can scale up and scale down these things. For now, we just be happy with what we have done. We have communicate using microservice using TCP protocol. Okay. Any questions up until this, guys? Probably you guys need to do lot of training on this if you are new to the application and everything. But simply you will get an idea really easily. Okay. All right. Let me stop you there. Let's stop that. Okay. Yeah, I know some of these concepts